Good morning, everyone. Welcome to the Editorial Edge once again. I'm Bhuvan and we are back after a brief break. However, what's not changed is the commitment to understanding topics, making sure that we have all the right knowledge insofar as a particular topic is concerned. All right. And so that's going to be our agenda today also. And so very quickly, we'll kick off this class. We have three topics that we'll take a look at. All three of them are interconnected. The first of that is that we'll take a look at the Aditya L1 mission because again, that has been in the news. And ISRO has made several announcements regarding it. So we'll take a look at the Aditya L1 mission, and thereafter, straight away we'll seek to understand, say, the Lagrange points. We'll revise it for those who are the regular watchers. For those who are joining for the first time, we'll revise, and in fact, we'll take a deep dive into understanding the different Lagrange points. And thereafter, we'll finish the class with understanding about the sun, okay? The different zones of the sun, all the different terms that you hear about, say, solar flares, or say coronal injections, all of that, CMEs, all of that will be taken care of. All right. Okay. Subhankar, good morning. Bulbul, good morning. Rajan, good morning. Shubhankar, it's going to happen twice a week as scheduled. It will be taking place. I'll update the timings on the Telegram channel. Pranjal, good morning. All right. Let's get started today. So first, Aditya L1, then Lagrange points, and thereafter the whole conversation around suns. If you're joining me for the first time, well, here is my Instagram channel. Scan this, become a part of it. If you have any particular doubts that you'd like me to address for you, you can send it to me there. Well, this is the Telegram channel, in fact. So go ahead and scan this and become a part of this. And I really suggest that you do, because all the PDFs and all the lecture material, the question material, everything that supplements the classes that you attend online will be found here. Okay. And obviously, just one student asked about, say, the Aranya series, which was again a credit to this group, the members of this group. They in fact were the ones who suggested that, well, we should have an environment ecology series for UPSC 2024, for which we have already completed 4 lectures. All right. Okay. So first we'll take a look at the questions of the last class, since it has been almost 2, 3, 4 days since we took questions like we did a whole session on Editorial Edge. So to revise, we took a stab at understanding about, say, the different criminal justice systems. And thereafter, we understood what IPC is about, what CRPC is about, and what Evidence Act is about. Karuna, good morning. All right. So with that, we had understood the difference between substantive justice and procedural justice. Okay. The substantive part deals with crimes and punishment in criminal law. In fact, it tells you about the do's and the don'ts. And the procedural part is the process that is to be employed if you do the don'ts. Okay. If you break any law, how is the state going to come after you and penalize you for it? That is the procedural part of law. All right. So the procedural law deals with the making, administering, and enforcing the substantive laws, those laws that you can't break. Okay. The rights, the procedures, everything is in the substantive part of the law. All right. So in this case, the primary legislation on procedure is not the IPC, which is in fact the substantive part of the law. You are looking at the CRPC, which deals with the procedure. So the incorrect statement here being 3, the third one, C. All right. I hope that's clear. Right. Just let me make a slight adjustment so that I can see your chat boxes properly. Okay. Great. Seems fair. All right. Next question. Cognizable offences, arrest with warrant. Non-cognizable offences, arrest without warrant. Bailable offences, offence bailable under existing law. All right. Cognizable offences are those wherein you cannot be arrested with or without warrant. Tell me, guys. Tell me, the chat should tell me. What's your interpretation? Those who are watching this live, tell me. Are these two correctly matched? A and B? Go ahead. Quickly let me know. The chat should become a part of this. It's early morning. Wake up. Get your mind working straight away. The third one is correct. Okay. Those offences that are bailable are called bailable offences, obviously. What about cognizable and non-cognizable? The class should straight away answer me in the chat box. Okay. Let's look at the next one. India uses the common law system in the delivery of justice. Indian Constitution empowers the President of India as the guardian of law, and SC can admit petitions in case of serious human rights violation or anything that is filed with the reference of Article 32 that talks about right to constitutional remedies. Your right to seek justice at the highest court of the land. Okay. That is guaranteed under Article 32. Okay. So the correct statements here being all three. A, B, C are correct. All right, let's look at the next one. Indian eagle owl is a diurnal species. Well, a diurnal one is one that is in daytime, whereas a nocturnal one is during night time. So you find that the eagle owl is a nocturnal species, in fact. All right. It has a distinctive ear tuft, correct. They are characterized by two-note calls, especially by the males during breeding season. The correct statements here being B and C. Fair enough. Cognizable is without, correct, and non-cognizable is with. Absolutely correct. Good attempt, guys. All right. Next, police action, Hyderabad, Op Polo. Okay, Sardar Patel, and he's credited with the Operation Polo. Thereafter, referendum was carried out in Junagadh, an instrument of accession with the Maharaja Hari Singh that led to J&K becoming a part of India. All right. So finally, the three statements here correctly being matched are 1, 2, and 3. All of them being correct. And these are by individuals. Well, Rahul's name has gone astray, but the rest. Thank you for your participation. Pranjul, Mama, Shubham, Pooja, Tanu, Mandeep, Evergreen, Karuna, Aditya, Akshay, and Rahul. Thank you for your participation. I hope that you carry forward the momentum. To the rest, well, I don't have many questions for you today, so you escape in that sorts. But I will be uploading questions on my Telegram channel post-lunch, okay, which will be, in fact, directly with relation to the topic that we will cover today. So I suggest that you go ahead, scan the barcode of my Telegram channel, become a part of it. All right. Okay, let's get forward. And today, so we'll discuss Aditya L1 mission. All right. And in that case, the first thing that you should understand straight away is that it is a first ever sojourn towards the sun. Okay. This is India looking to study the sun up close for the first time. So let's look at a few facts of the case first. Okay. The first space-based Indian mission to study the sun, well, the approximate date that has been put forward is August the 26th. However, that's not important for us. What's important for us is to understand that this whole mission is going to be based out of a halo point, that is Lagrange position 1. Okay. In a halo orbit around the Lagrange point 1 of the Sun-Earth system, which is about 1.5 million kilometers from the Earth. So straight away, your first understanding here is that, well, if this is, well, this is a blue Earth, okay, and then you have the red sun. All right. Now, what you are looking to do essentially, and understand it in the simplest manner, okay. So now here is Earth's orbit. All right. Now, anything that is inwards towards the sun, you know that it will have a smaller orbit than the current Earth's orbit. Yes. That will be much more closer to the sun, which means its period of revolution around the sun will be faster. Its speed around will be faster. So now, what is the problem here? Essentially, what we are looking to do is find a point between this area, between the Earth and the sun, all right, wherein you are able to counterbalance the gravitational pull of the sun with the gravitational pull of the Earth, okay, to find that sweet spot, okay. And so that position is, in fact, what is it's found to be is in a straight line. And therein is a particular position called point L1. Now you might be asking me, so what's the point? Why is it that we need to go, say, to point L1 to study the sun? Why can't we do it up from here? Well, that's a fair question, but realize that there are a lot of objects, firstly, that will hinder you to study the sun. The space debris being one, which is often found in this area, the low Earth orbit. Okay. At the same time, any other place wherever you put in your whole the whole mechanism to study the sun, you have to take in the cost factor. Okay. You need to make sure that you're using the most minimum amount of fuel and getting the most maximum amount of, in fact, exposure of the sun. All right. So this is the whole point of it. L1 point is that point where you are able to balance the gravitational pull of the sun with the gravitational pull of the Earth. Even then, what you're going to find is, to maintain that particular focus all throughout, you are going to use thrusters. There will be some amount of adjusting and maneuvering required. All right. Now, is ISRO going to be the first one to go and land at this place, L1? Well, no. Okay. Several missions in the past have gone there, including the SOHO mission, Solar Parker mission. All right. I'm going to note them down for you. And well, we have discussed them, so I'll briefly build on them later. But these are the major missions that have already been in this place. Okay. One of them is with the ESA, one of them is with the the NASA. So you will take a look at that. However, I'll give you the information. You don't need to worry about that. Shubhankar, I absolutely agree. ISRO is one of the flagship organizations of the country we all should be proud of. Absolutely. Okay. Now, let's look at this. Once you have understood L1, the whole story becomes clear. A satellite placed in the halo orbit around the L1 point has the major advantage of continuously viewing the sun. Look at it. Firstly, you have avoided all the problems that were there at the low Earth orbit, all the space debris, everything that was there. You have gone closer to the sun, which means now you have an unhindered view. At the same time, you receive the sunlight faster than Earth. Okay. Obviously, it takes 8.5 minutes approximate for the light to travel from sun to Earth. You are already at an advantage, which means you are going to harness solar energy better. All right. You are also looking at what? Here are the other ones. Okay. Greater advantage of observing the solar activities in its effect in real time, and thereafter, this is the whole L1 point. Look at it. Here is the Earth, here is the sun. What you are looking at is that sweet spot in the middle. Now, what is the counter argument to this? That, well, because you are, say, in that inner orbit towards the sun, your period of revolution will be shorter, which is why, say, Mercury goes around the sun in, say, 47 days, whereas we take, say, 364 days to do it. Okay. But then, to balance that, you are going to use the gravity of both Earth and the gravity of sun so as to maintain that constant singular line in which all three are completely together. Okay, so that's your Lagrange point 1. Now, what are Lagrange points? Named after a scientist, not very important to know, but these are positions in space where the gravitational forces of a two-body system. This is your two-body system, gravitational field of Earth, gravitational field of sun. You are just going to balance it. Okay, you are going to just go ahead and balance it. Okay. Now, these can be used by spacecrafts as parking spots to remain in a fixed position with minimal fuel consumption. Essentially, it's about reducing the cost of the mission, guys. Okay. It's about reducing the cost of the mission. So, you are going to harness the natural gravitational forces of the sun and Earth to make sure that your cost of the mission is minimum. Okay. Now, the closer an object to the sun, the faster it will move, like I told you. So, any spacecraft going around the sun in an orbit smaller than the Earth, if this is the Earth's orbit, if your orbit is anywhere inwards, you are going to complete that revolution fast. You are going to go faster than the Earth, which is why the loophole is being exploited. If the spacecraft is placed directly between the sun and the Earth, the gravity pulls it in the opposite direction, and thus you are looking to find balance in the system. Once you achieve balance in the system, your L1 is done. Okay. So, this is your point L1. Now, let's look at L2. Similar way, here was L1 between the Earth and the sun. Now, you are looking at L2, which is beyond the Earth. Now, some might ask or some might wonder, what's the point of this? Okay, in L1, you were looking to look at the sun, observe the sun, study the sun. What about L2? What are you going to study beyond the Earth? Well, what's essentially the point of understanding here is that if you are looking to study deep space, okay, what you need is a zone of darkness. If you were to study deep space from, say, L1, it's like trying to look into the sunlight, or it's like trying to look into the headlight or a torch. Okay. For example, if this is a dark room out here, and if I just put a torch in your face, will you be able to observe anything in what lies behind me? No. That's the whole point of it. However, if the torch were the camera, if I was standing here, and if you were right behind me, you would get a zone of darkness in which you could study the space, the universe. This is the point of position L2. Alright. A similar effect to which L1 is also occurs on the night side of Earth, which means you're looking to go beyond the Earth to the side which is in darkness. Okay, which is in darkness here. This is the side you're going to. Go ahead and consider. Alright. So now, any spacecraft placed there is more distant from the sun and therefore should orbit more slowly, obviously. The moment you go outside, inwards towards the sun, your orbital speed will be fast. But the moment you go outside, you will find that your speed is going slower. Your elliptical orbit, that much bigger arc you are having to cover, right? Which is why you find, say, like planets like, say, well, not planets now, but Pluto takes a lot of time to cover one particular elliptical orbit around the sun, whereas Mercury does it in a relatively quick time. Okay, so now with that logic having been established, what you're finding is that the extra pull of our planet, the gravity of our planet once again is being harnessed to add to that of the sun, and then allowing the spacecraft to move faster, keeping pace with the Earth. It's moving once again in consonance with us, because that's the whole point. If you have unequal speeds here, then that zone of darkness moves. Then the whole point of L2 is lost. L2 is only useful if that zone of darkness is maintained throughout vis-a-vis the sun, which is why you need to have equal speed between both the spacecraft and the Earth, which is what's happening here. You're using sun's gravitational force along with Earth's gravitational force once again to maintain balance in the system, right? So again, L2 is located 1.5 million kilometers behind us towards the night side. All right. It's a great place from which to observe the large universe. In fact, deep space missions, okay, all the observing missions for deep space, all the telescopes that you have, say Gaia, Herschel, Planck, James Webb, yes, here are they. All of them mentioned in point L2. Now your homework will be to go back and look at each of the launching agencies for each of these. Say Gaia, for example, is of the European Space Agency, the ESA. Go ahead and look at the rest of them also. Okay, do that for me. Alright, let's look at L3 now. Now in L3 what happens? Here is L1 first, between the Earth and the Sun. Here is L2, towards the night side of the Earth. Here you have L3, behind the Sun. Now what happens? What's the point of going behind the Sun? Well, eventually, this is also a stable place that you're looking to get. In terms of, say, well, when you study Lagrange points, what you're studying is two types, okay? One are called stable points, and the other are called metastable points, right? We'll understand this very quickly, what are stable and metastable points. All right. So now when you go behind the Sun, do you realize what's happening here? You are essentially getting again into a zone of balance, but it's a very precarious balance, you know. So you need to quickly go ahead and use your thrusters from time to time to make sure that you stay in that balance, or else once again you go out of the L3 zone, okay. So L3 lies behind the Sun, opposite Earth, just beyond our planet's orbit. Please understand, because it is behind the Sun, okay, the obvious inference should be that communication will be a problem, okay. For example, the Chandrayaan mission, say when it is going and say completely taking one orbit around the moon, ISRO for say certain time, when it is towards the other side of the moon, not the one that is facing Earth, when it takes that particular revolution, you are going to find that communication is often not established, lost, or say briefly it is interrupted. So when communication can be lost in say as proximity as moon, well, what happens in case of Sun? There is going to be no communication, which is what one of the major drawbacks of the L3 point is. That communication is not going to be established on a continuous basis. Once again, why? Because it is behind the Sun. Alright. So again, a spacecraft at L1, L2 or L3 is metastable, like a ball sitting on a top of a hill. Okay. So your metastable points are L1, L2, L3. They need to go ahead. What's the meaning of metastable? That thrusters of the spaceship or your particular instrument that you have sent upwards, it needs to be employed from time to time basis to maintain balance, to maintain stability. Okay. If you do not use your thrusters, you will lose stability. However, there also exist two particular points, Lagrange points L4 and L5, in which you don't need to use thrusters. Okay. In that, what you are essentially looking to do is just completely negate the whole gravitational field of Sun and the Earth. In this, you are playing with them. Okay. L1, L2, L3. You are playing with the gravitational field of both Sun and the Earth to find, say, some sort of stability for a brief time, and then use fuel to maintain that stability throughout. However, in L4 and L5, you're not looking to do that. Okay. So let's look at L4 now. Now what is L4 and L5? Essentially what you have to understand is that, well, okay, let's understand it this way. Let me draw it out for you. Okay. So here is Earth, here is the Sun. Okay. Now please understand, if this is the Sun's gravitational field. Okay. Now this is Earth's gravitational field. Obviously smaller than the Sun because, well, it is directly proportional to the, say, mass, the size of the whole object. Now what do you find? That eventually Sun's gravitational field and Earth's gravitational field, let me draw that from two different colors so that it is easier for you to decipher. Okay. This is Sun's gravitational field in yellow, and we will use, say, green for Earth's gravitational field. Okay. So this is Earth's gravitational field. What do you see here? This particular zone, guys, and this particular zone. Do you see that this is a zone where there is no interaction of both the gravitational fields of both the Sun and the Earth? Right? In all the other positions, L1, L2 and L3, what you see is you are essentially under the influence of either, in fact, all the two bodies, Earth and Sun. But in L4, L5, you're not interacting with them at all. You are in that zone of darkness, zone of absolute exclusion of gravitational field, which means you don't have to worry about stability. It is already a stable position. Okay, which is what L4 is and L5 is. Please understand, they are at an angle of 60 degrees. Okay, 60 degrees. Essentially looking like this. Okay, this is essentially your Lagrange point 4 and 5, wherein again considered to be stable. You are not going to use thrusters on a continuous basis to maintain stability. Clear hai sabko? So this is what L4 and L5 are. Let's look at it. L4 and L5 points lie at 60 degrees ahead of and behind Earth on both sides. Alright, this is the angle they are making. 60 degrees on both sides. Here is L4, here is L5. Alright, here is your Earth. Okay. So unlike the other Lagrange points, L4 and L5 are resistant to gravitational perturbations. See, they are excluded from the gravitational effects, the counter effects of both Sun and the Earth, which is what benefits stability in these two positions. Okay. And at L4 and L5, you're considered to be truly stable. So your learnings from this, guys, exam perspective, L1, L2, let me write it down properly. L1, L2 and L3 are called metastable. Okay, you understand why? Because you're going to use your thrusters on a regular basis. L4 and L5, they are completely stable. Okay, where is gravitational interaction of, say, both the two body system, the Earth and the Sun, like being used extensively? Well, in these two. Here, you are getting excluded from the gravitational effects of both the bodies, which is why you are considered completely stable. Okay, is that clear? Alright, if that is clear, first let me know. If you understood Lagrange points in detail, let me know. Leave me a like so that I understand all those who are watching understood Lagrange points in detail. Once again, I suggest those who have joined me late, make sure that you go through the last 20-25 minutes. This is extremely important from the exam point of view. Okay, the payloads are obviously important. The work of the payloads is also important. What they are going to study is also important. But then where is it going to be positioned and why is that position being used is of utmost importance for you to understand. Okay, so L1 and L1, L2, L3, L4, L5 should be absolutely clear now. Okay, okay, all right. Let's move forward now and understand Aditya. So now Aditya L1 mission, you know it's going to Lagrange point 1. What has it got? It has got 7 payloads on it. And it is going to study all of these terms. Photosphere, chromosphere, corona. What are they all about? Let's understand that first. Then we'll understand what is it carrying to study what. Okay? So let's understand the surface of the Sun first. Let's go there. Okay. Fair enough. This is the Sun for you. Now a major misconception is, okay, major misconception that most students have is that the Sun is, say, a solid body. It is a ball of fire. That is what we are taught. Okay. While that may be true, what is absolutely true is that the Sun is a non-solid body. Okay. In fact, what it is made up of is completely gases, and a lot of interaction of those gases is violent. Okay. So if you want to note this down or write this down, now would be a good time. आप थोड़ा सा लिख लो पहले इसके बारे में. Okay. So you're looking at several zones and layers of the sun. And so if you go from inside out, okay, from the inside to the outside. So the first one obviously is the core, much like our earth, right? This is our core. Now what is happening here? Exactly at the core of the sun, what's happening is that hydrogen, all right? The whole story is of just two particular things, hydrogen and helium. So what is happening is that nuclear reactions are taking place, okay? Nuclear reactions are taking place here, okay? And they are consuming hydrogen to release helium. Is that clear firstly? I'll tell you, Shubhankar, just a second. Focus on the core zone of the sun first, okay? So what's happening is nuclear reactions, violent reactions using hydrogen and then forming helium. Okay. Now in this violent process, energy is being released. Okay. Energy is being released, and massive amounts of energy. Huge amounts of energy is being released because again, these are nuclear reactions taking place. That energy that is being released is the primary credit for the light that we see. First understand that. Clear hai? Okay. Next, after the core zone, we have the radiative zone, or they say transitional zone, you can call it. Okay. The radiative or the transitional zone. Now this extends from the outer edge of the core. Okay. From the outer edge of the core up until say upwards towards say the base of the convection zone. All right. This is the radiative zone here. Clear hai? Now here what is happening is, why is it called radiative zone? Because again the primary form of energy transport here is radiation, which is why it is called a radiative zone. The energy transport primarily is happening through radiation now. Clear? And finally, after the radiative zone, you have the convection zone. Okay, where the convection form of energy transfer is happening. Convection, radiation, all of these are basic NCERT levels as to how heat transfer happens, no guys? I'm sure you must be aware of that. What are the other forms of heat transfer? Let me know. Two I have told you, convection and radiation. What's the other form? Let me know very quickly in the chat. See, NCERTs you must be absolutely aware, which is why only then you will be able to understand these concepts in detail. Okay. So now once we have understood core and radiative, come to the convection zone. Convection zone is to do with the outermost layer. Okay. This is the outermost layer, obviously. All right. And what is happening here? This is the outermost layer where a lot of convection is happening. Eventually, heat is getting transported to the surface. That heat eventually is so much that you are able to feel it here. Correct? So these are the three primary zones that you are seeking to understand. Now, in terms of atmosphere, okay, this is what I have told you, say, about the inner workings of the sun. What about the sun's atmosphere now? Because sun also has an atmosphere. So let's understand sun's atmosphere now very quickly. All right. Number one, firstly, is the photosphere. All these terms in this particular slide, in this particular diagram that I have introduced before you. Okay. Now, what is the word photo mean, guys? Does it mean light? Does it mean light, guys? Batao mujhe. Huh? So essentially this is the visible part of the sun. Alright, the visible light of the sun originates from the photosphere. Then you have the chromosphere. Have a look at this. You see, first you have the photosphere, the outer red region. Thereafter you have the chromo one. So understand chromo. What is chromosphere now? If you're noting this down, good, or else you will be getting all of this in the slides. So don't worry about that, guys. Okay. Now the chromosphere is essentially above the photosphere. Okay. Just above the photosphere. Okay, and what's the work of this? Here essentially what you're seeing is that temperature rises very quickly. Okay, temperature rises very quickly here. Okay, photosphere, chromosphere. Then you also have a transition zone here, and eventually after you have gone through the transition zone, you come to the corona. All right. Now, what is the corona? Essentially, it's the sun's outermost layer or outermost part of the atmosphere. Okay. These are the various zones that we have studied insofar as the sun is concerned. Okay. Now, what happens in the corona? Corona is actually the region from where you find all of these solar flares, okay, sunspots, what else is there, prominences, all of that originate from the outermost part of the sun's atmosphere, which is called the corona. Now you are seeing certain terms that I've used here, prominence being one, all right. There is also sunspot. Now we'll seek to understand what are they. Look at sunspot here, guys. Do you see it's like a pimple, it's like a dark spot on the sun's surface? Why would it be dark? Think of it that first. It's dark because the temperature of that place is low. That particular part, the temperature is low. Why is it low? Okay, what could be the reason? Let's seek to understand that now. Here is it. Now, very important in terms of the exam perspective. Okay, I suggest that you go through this slide. I've picked it from the ESA website. So it's completely it encapsulates all the particular theory that you need insofar as sun is concerned from the prelims perspective. Okay, so let's look at sunspot. Darker, cooler areas on the photosphere with concentration of the magnetic field, because again these nuclear reactions are taking place. So much of energy is being released. So obviously sun's magnetic field will have a role to play in it. Okay, all of these violent processes are essentially what? Also to be interpreted from the magnetosphere perspective, the magnetic perspective. So because of the magnetic field, the varying concentrations of magnetic field within the sun's own sphere of influence, what you find is that certain areas go cool, then suddenly they'll come back to the normal temperature. By the time that intervening period when they are cool, so they lose color, they become black, which is observed on Earth as sunspots. Okay, so you're looking at sunspots, prominence, okay, which is again say it's an outward extension of the sun's outermost corona. A lot of material is released, that is prominence. Okay, so a very important slide. I have given you the basics of it. Okay, so what is core, corona, radiative zone, transition zone, convection zone? Okay, the processes is essentially to do with two elements, guys. From the exam perspective, you will remember that hydrogen is being used as a fuel here for the nuclear reactions, and eventually the product that you're getting out is helium. And the massive amounts of say both these gases present along with the violent reactions that use these two elements, which is what gives sun the aura that it has. You know, the whole ball of fire that we consider is because of these violent reactions that are taking place. Is that clear? Nuclear fusion reactions. Clear? Okay. So now let's look at sunspots. Dark areas on the photosphere caused by intense magnetic activity. You will remember this part, the cause of sunspots. Okay. These regions are cooler, which is why they are seen as darker on the sun's particular surface. Okay. And what happens? What is the reason? Because the magnetic fields are inhibiting the process of convection. Such is the magnetic field of the sun because of its obviously size, its influence, okay, which is why you feel that it interferes with the very convective process that makes sun the sun. Do you understand that? Okay, we are looking at solar flares, sudden bursts of energy and radiation caused by the release of magnetic energy in the sun's atmosphere. So straight away when solar flares hit the earth, you find that our telecommunication systems, our space satellite systems, they're completely affected. Okay, Hakesh, welcome, good morning, good morning. Okay. Then you are looking at CMEs, coronal mass injections. Corona, that you know is the outermost layer of the sun now. That much you know. Okay. Now what happens here? large explosions of solar plasma. Now, what exactly is plasma? This is essentially supercharged gas. Okay, supercharged gas. So, this supercharged gas is thrown out by the sun. Why exactly is this happening? Have you considered? Okay, sun is going through all of these processes. Why exactly is it happening? Because essentially, every celestial body seeks to achieve stability. Okay, and the sun again is a violent ball of fire going through all these nuclear processes. Essentially, it seeks to achieve stability. For that, it will undertake whatever maneuverings it has to do. For that, if it has to go ahead and release solar flares, it will do that. Why is this being done? Because eventually the sun is a star, and the life of a star sees these processes. Eventually, the outcome of the sun, say in a million or 22,000 million years, or n number of years, whatever it be, the outcome of the sun is what? Can someone tell me? What's going to be the outcome of the sun? Batao. Say in a n million years, okay, what's going to happen to the sun? There's two ways this story can end for the sun. One, that say it goes and becomes a neutron star, or two, it goes ahead and becomes a black hole. Okay. Now, what is a black hole? Again, that's a different conversation, but primary misconception that I find among the students is that black hole is something that consumes space, matter and material. No, that's not black hole, okay, by the way. Don't get into that misconception. Black hole is similar to, say, a particular star, only that it has, say, lost the fuel to carry out the life of a star. It's at the end of the life cycle of a star. Okay. Subhankar has a question: if there is high magnetic field, then that area should be rich in minerals. You can say that, Subhankar, to a certain extent, but then it will not be in a manner in which you can harness it. Do you understand that? It's already being consumed by different reactions, which is why you can say that even though it will have, say, eventually it will be in a molten form, in a lava form. So there's not a lot that you can really do out of it. Okay. Solar wind, a constant stream of charged particles emitted by the sun, which affects the Earth's magnetosphere and contributes to space weather. Okay, make sure that you know the differences between these four terms: the sunspots, solar flares, CMEs and solar wind. Okay, from the examination perspective, I suggest that you know the basic structure of the sun. Okay, photosphere, chromosphere. Make sure you know about the core and the corona. Alright, thereafter make sure that you know about the processes that are involved, specifically the hydrogen-helium relationship, and also seek to understand all these four terms that originate out of the sun. So also we have discussed the whole L1 to L5 Lagrange points. Now that we know what we are sending, okay, where we are sending and what we are seeking to study, now let's understand what we are sending. Now it will make sense. Okay, so let's look at a few facts though, very quickly. So 100 times wider than the Earth and about 10 times wider than the Jupiter, the biggest planet. If the sun were as tall as a typical front door, Earth would be about the size of a nickel essentially. We're looking at a coin size, such is the difference, which is why you find that the gravitational pull of the sun is far higher than that of the sun, of the Earth. Which is why when you look at the Lagrange points, to find that sweet spot, you can't go too deep. Because the moment you go too deep towards the sun, firstly again the temperature rises. At the same time, the sun's gravitational pull is such that you risk losing your spacecraft. Which is why we are looking at, say, going deep, but to the point where you can counterbalance it with the Earth's gravitational pull. Clear hai? Okay. Now the sun is the only star in our solar system, the center of our solar system. Its gravity holds the solar system together, and essentially it's the center of our universe. Now how is the day measured? Now the learnings from this particular is only this part for you guys. Okay. That the sun's surface isn't solid. Please understand that first. It is made up of super hot electrically charged gas called plasma. Okay. Supercharged gas. That is plasma, and that is what essentially makes the sun, along with the reactions that are taking place in it. Clear? So this plasma rotates at different speeds on the different parts of the sun. At its equator, the sun completes one rotation in 25 Earth days. At its pole in 36 Earth days. Okay. Some FAQs from the sun essentially that I have given for you that you should be aware of. Okay. That the length of a day is not constant. The day as we know it is not constant on the sun. Okay. the way it is also acting and counteracting in the universe is different, which is why you find that at the poles it is different, and at the equator the rate of rotation is different. Okay, so these are the FAQs that I have for you. All right, have a look at this, but very quickly let me go through and show you the payloads on Aditya. Okay, yes, this is the one now. Now that you understand, say the different parts of the sun and say what constitutes the sun's atmosphere, now let's look at what we are sending to study what. So we are sending visible emission line, coronagraph, corona, the outermost layer of the sun, which means you are looking at going ahead and imaging, taking photos of the outermost layer. Next, solar ultraviolet imaging telescope to study the photosphere and chromosphere. Obviously, from the outermost, you will go inwards, wouldn't you guys? If you are sending a space mission, not just the outermost part of the sun, but also you are going to go inwards after that, which means you are going to first understand chromosphere, thereafter photosphere, thereafter, what's the last one, guys? Bataiye mujhe. Okay, you are also looking to study the different spectrometry. You're going to look at spectrometry, look at the star as a whole. Okay, look at its emissions. What are the different wavelengths of emissions? What causes, say, sunspots? How does a sunspot dissipate? All of this can be observed only when you observe the sun up close, unhindered from, say, the space debris and everything, all of that. Okay, which is why L1 is being used by ISRO. Now look at the other payloads. Aditya Solar and Particle Experiment aspects, where we are going to study what? Solar wind. We just discussed what is solar wind. Clear? We are looking at plasma analyzer. What is plasma? Supercharged gas. We are also going to study the gas concentrations. What are the gases that you're looking at? Hydrogen and helium. All right. And you're looking at going ahead and looking at magnetometers. Why? Because sun's magnetic field causes, yes, so many interactions we discussed today. One of them being that it causes, say, solar dark spots or solar spots. So what else can we study from sun's magnetic field to figure out, get out more information about the sun? Clear? So this is in fact the whole Aditya L1 mission. Let's look at these particular concepts that I had for you. Yes, two of them that I really wanted you to take note of is one, that the sun does not have moons. Okay, again, it's a very commonly known thing, but from the exam perspective, at least make a mental note. Okay, that the sun does not have moons, even though, say, it is at the center of the universe. Everything from planets to asteroids to our moon, in a way, everything is focused around the sun. And yet, in spite of that, you find that the sun does not have moons. What are the different space probes or space missions that have been sent so far to study the sun? Okay, you're looking at the Parker Solar Probe. Which organization? You will let me know. The Solar Orbiter, SOHO. Okay, all of these are different space probes. I suggest that go ahead and look at the launching agencies of each. Okay, make a brief note of each. Who is the launching agency for what? At least whether NASA has done it, whether ESA has done it, whether Roscosmos has done it, whether Japan agency has done it, China has done it, ISRO has done it. ISRO is doing it, in fact. It's a first ever attempt. So the rest must have done it. Go ahead and figure out who has done what. Okay, let's look at the rest. Now look at this, guys. I hope this is clear. Can you see this particular fog here? Can you see this fog? See, if this is the sun here, okay, this is Mercury, these are the different planets after them. Can you see this particular line of fog here? Huh? Can you see this? What essentially is this called? Now this is called sun dust or dust rings. Okay. Now why did that happen eventually? Because when the Big Bang happened, okay, so it was essentially what? A massive explosion of dust and gas and supercharged particles in the atmosphere, in, say, the space. And eventually, see, gases coalesced, dust coalesced to become planets. However, there were several of these millions, billions, trillions of particles still in the space. So now what has happened is that these dust or this particular remnants of that particular 4.6 billion years ago, yes, Some of that dust is still around today in several dust rings which circle the sun. They trace the orbits of the planets whose gravity tugs the dust into places around the sun. So our Earth's orbit also has a lot of sun dust in it. Equally, Mercury also has, Venus also has, Mars also has, all planets. Why is that? Because eventually that coalescing that happened, eventually that formation, the process of coalescing happened, wherein eventually it went on to become a planet. Well, there were several other dust particles that were not included. Okay. Obviously, there were several other stray dust also in and around it that were a part of that whole process. Which means dust rings originated out of the Big Bang and now a part of that particular orbit that a planet has. Okay, so make a note of this, because again you wouldn't probably find this in the NCERTs, at least I didn't find it. And so it helps you to be aware from the examination perspective. Alright. Okay. Alright. That's pretty much it, guys. We have discussed in say less than 45-50 minutes. I have discussed the Aditya mission with you. Okay, the basics of Aditya. We have discussed L1 to L5. We have discussed Sun. Alright. Now the questions for this are coming at 12 p.m. around 12 p.m. to 1 p.m. on this particular channel. Okay, go ahead to the Telegram channel, scan this, and you will find that a bunch of MCQs from this particular lecture will be uploaded there. Go ahead and answer them, and this will be a regular feature going forward, guys. Every morning 6:30 to 7:30 we'll meet for 1 hour, take a topical look at an analysis at a particular current affairs topic that you should be aware of. Okay, and not just aware of, say, what payloads is ISRO carrying. Yes, of course, that obviously is expected of you. But then what function will be the payload? What will be the function of the payloads? What are they seeking to study? How are they seeking to study that? Those questions should be normal in your particular consciousness. Yes, absolutely. Okay, so go ahead and do that, and wait for my questions. I'll be uploading that on my Telegram channel, and I hope to see many of you tomorrow morning. If you enjoyed this discussion, go ahead, share this with your friends, those who you think will be benefiting out of this. Okay, we need to have more participation of students as we take this series forward for UPSC 2024. All right, thanks everyone. Have a productive day, and I shall see you tomorrow morning, 6:30 a.m. Bye.